Okay, students. So today we are going to take a practical on how the Rockwell hardness tester works. Okay, we are going to use the digital hardness tester to find out the hardness of material. Okay, we are having one workpiece. On which we are going to take a test, conduct a test of Rockwell hardness tester. Okay, this will show. Actually, there is two types of hardness tester we generally use in your syllabus. One is a Grinnell hardness tester, one is Rockwell hardness tester. In a Grinnell hardness tester, the diameter of the indentation is measured, and in a Rockwell hardness tester, the depth of the indentation is measured. Both the machines are here. We are using the digital and automatic machines, which will directly give you the hardness value of the material. Okay, now we will use the ball indenter, which is 1 by 16 inch ball indenter, and we are going to use the scale HRB. Okay, so there are various scales we generally use. I will explain you in detail. We will use this anvil, and this is a digital Rockwell hardness tester where we are going to conduct a test. Okay, so here we will put the anvil here. First of all, start the machine. We are going to start the machine. Okay, here we will place the sample. Okay, this is the hand wheel. By using this, we can move the anvil upward and downward direction. This clockwise movement of the hand wheel will up the motion, and with this anti-clockwise hand wheel will show the down the motion. Okay, now we will put this indenter. This is a ball indenter. Ball indenter we will put in this holder. Okay, so by using this Allen key, we will tighten it to hold that specific ball indenter. Okay, so this one is tightened. Now we have placed the workpiece over here. Now there are three things that we are going to conduct in this. The first step, we have to understand the scale. Here you can see there are different scales generally used on a Rockwell hardness tester. A, B, C, D up to the V. For every scale, for which type of material, which type of scale is used is given on this chart. Okay, if we are going to find out the hardness of an aluminum alloy, then we use the B scale. For B scale, we use 1 by 16 inch ball indenter, for which the load is 100 kg. Okay, so aluminum, copper alloys, and hardened steel, rolled drawn, extruded or cast metals. If we are going to find out the hardness of this type of materials, we use this P scale. If we want to find out the hardness of a carbide, thin steels, shallow case hardened steel, case carburizing surfaces, then we use A scale. And for the A scale, there is a diamond indenter is used. You know that diamond is the hardest material in the world. So diamond indenter is used to find out the hardness of carbides. Okay, and the load for this scale is 60 kg. Okay, if we use a C scale is generally used for hard cast iron, perlite malleable steel, then deep case hardened steel, titanium. For this material we use the C scale. For the C scale, diamond indenter is used and the load is 150 kg. Just likewise, all the scale for which material, which type of scale is used, according to that we have to change the load and the indenter also. Here in this side you can see there is a load. Different loads are there. We can say 150 kgf load is there. We can select by this 100 kgf load is there and 60 kgf load is there. According to the different scales, we use the different load for this find the hardness of different materials. Okay, 60, then 100, 150 and 100. This is a knob where we unload and load the load. Okay, here this side it is loading and this side it is unloading. Okay, now here is the screen. See here. Okay, so here is a digital screen, digital Rockwell Hardness tester. Here is the main menu. Here we can see the setting. Okay, by clicking on this, enter. Which type of scale is used here is indicated. HRB. The scale is HRB. If you want to change this, click on the HRB. Then we can change this scale by using this CS button. Now you can see the scale is HRC, HRD, HRE, HRF, HRG, HRH, HRK, HRL, HRM, HRP, HRR. These type of scales are generally used on this machine. So this we will set HRB scale for our convenience. Okay, as the material is steel, so we use this HRB scale. Again, there is a limit for the hardness. Every material there is some limit, high limit and low limit. We can say the upper tolerance and lower tolerance. We can say. Okay, so upper limit and lower limit is fixed by using this. For this specific material, I will choose the upper limit. Is here. Scale HRB upper limit. We want to change upper limit. I will say it is 90. It is 99.5. Okay, I will set it. Then next is low limit. I will set the low limit to 95.5. Okay, so enter. Then next is dwell time. Dwell press is the point up to which we apply the load. Then dwell load for timing is 0 second. Dwell recording is 1 second. If you want to print, it can print the record also. Cycle is auto. Then this all type of setting is done. Correction is not required, so scale is set. Okay. Now reset it. If we press reset, it will show this. Now we are going to conduct the test. How we are going to conduct the test is, this is the workpiece. Here is the workpiece. We push this workpiece over here by touching it. Just come here. Here we apply the load. When it is touched to the set, here we applying the load. Okay, the set point is 130. Okay, we have set the load 100. Now we are going to apply the load. Okay, we have applied the load here. Now it is showing. Now this is the dwell time. Okay, now by this beep, after this beep, we release the. Okay, so here it is showing the hardness. Okay, so its hardness can be calculated by this. Okay. Okay, now we are going to apply the load on the specimen. Okay, here you can see lines will complete. Okay, value is beyond our limit, so it is very high. The hardness is very high. Okay, that high, its upper point showing high, this lower point showing it is hardness is very low. And if the hardness comes in between this go, it is very correct. Okay, so I'm ready. Okay, so this by using this method, by using this digital Rockwell harnesses, we are able to find out the hardness of different materials. Okay, thank you so much.